Students, today I am going to explain the topic name is hybridization. Yesterday I explained Lewis Costell's dotted theory, how they are forms the bond between the two atoms. Next, the theory which is the hybridization, how the bond formations, yes, how they are intermixed with each other, they can forms their bonds in between the two atoms like. So here the hybridization is, the definition can be also written as the same atomic orbitals A and B atoms of their atomic orbitals are, yes, A atom of their atomic orbitals, B of the atomic orbitals. These are all atomic orbitals, and B contains atomic orbitals, yes, same energy. It means like S P D D F S P D F D F S P D F, sorry, S P D F. These s orbital in hybridization, S is overlaps with S only, and by this causes it produces one sigma bond, and then P can be also overlaps with P, D, D overlaps with like this. So these are all atomic orbitals. Then this is B atom of atomic orbital. It is an A atom of atomic orbital. Both are intermixed by like this and produced their sigma bonds in between the two atoms. In between their sigma bonds like this. So, in which the bond formations will be taking place in between their atomic orbitals, which are intermixed with each other. A atom of the s orbital, B atom of s orbital is overlaps with, by this causes one sigma, and P P D D. So S and P orbitals are SP are approximately same in energy, by this causes they can produce, then S and P can be also overlaps with each other, they can also forms their bonds between them, yes. So hybridizations can be also taken as different kinds of hybridizations are there. Number one is sp3 hybridization, sp3 hybridization, sp2 hybridization, sp hybridization, sp3 dehybridization, sp3 d2 hybridization, sp3 d3 hybridization. These are the types of hybridizations. So now we are going to knowing about sp3 hybridization. What is sp3 hybridization? First one is sp3 hybridization, sp3 hybridization, in which the hybridization will be taking place in between 1s and 3p orbitals, 1s and 3p orbitals, which is called as sp3 hybridization it is. So in which the particular orbitals, 1s means, s means spherical shape, 3p means 3px comma 3py, and 3pz orbitals are there. It means 3px is dumbbell shape, it is an x-axis, it is y-axis, it is an z-axis. 3px, 3py and 3pz. So 4 atomic orbitals. So in this the atomic orbitals are intermixed by each other, they can produce the sp3 hybridization. Yes, I am going to take the molecules of examples here Examples from sp3. Examples is sp3 is CH4. It means CH4 means methane, and NH3 ammonia, and water molecule H2O, and then CCl4 is the examples for sp3 hybridizations. How they are involved in the hybridizations. So now I am going to the configuration. The first I am going to take the CH4 molecule for first one. CH4, it is an methane molecule. The central atom is carbon. Electronic configuration is 1s2, 2s2, and 2p2 is this. So in which the outermost electronic configuration 2s2 and 2p2 is the electronic outermost of carbon. So here p contains 2 electrons. It means 2s, 2px, and 2py, and it is 2pz. So in this the 2px, 2py, 2pz, it is an ground state of atomic orbitals. What is the excitation? We have 4 hydrogen atoms here, but here only 2 unpaired of electrons are there. 2 of unpaired of electrons, but we want 4 unpaired of electrons to form their bonds in between them. By this causes the s orbital of their electron which is enters into 2pz orbital. First excitation will be taking place by like this. So 2s contains only one electron, 2px and 2py. It is 2s and it is 2px, it is 2py, and it is 2pz. It is first excited state of an atomic orbitals of carbon. So here then the 4 hydrogen atoms, then one hydrogen, second hydrogen, third and fourth hydrogens, which contains 1s1, 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 and 1s1. So which contains of their are electrons, which contains like this. Each of hydrogen contains one electron in their atomic orbitals. By this causes the 1s orbital is intermixed with by like this 2s of 1 sigma. Then this one also like that, this one also like that, and this one. So 4s orbitals of 1s orbitals is intermixed with 2s, 2px, 2py, and 2pz. By this causes the molecule produced CH4 molecule. Then we can also take an as like this. The atomic orbitals takes place as like this. 2s means like this. This is the 2s orbital. That is 2px orbital, 2px, and it is 2py, 2py, and it is 2pz. It is 2pz orbital. So it is 2s orbital. It is 2px, 2py, and 2pz. By this causes which produced 1 sigma bonds. How they are intermixed with their s orbitals here. 1s orbital of hydrogen is intermixed with 1 sigma. 1s orbital of hydrogen is intermixed with 1 sigma. 1s orbital of hydrogen is intermixed with by like this. 1s orbital of hydrogen is intermixed with like this. By this causes then the molecule CH4 will be obtained by like this. So here the central atom is there, and 4 hydrogen atoms by like this. So one hydrogen, one hydrogen, one hydrogen, and one hydrogen, by which contains like this. The structure can be also takes place as by this 4 hydrogen atoms. Then the CC bond formation here 109 degrees 28 minutes. The bond angle it is. The hybridization is totally S. It means 1s. 3p means p3. sp3 hybridization. It is hybridization. Then molecule is sp3 hybridization. It is the CH4 molecule. And I am going to tell about second one is NH3 molecule. NH3. How the NH3 molecule will be formed here. NH3. Second one is NH3. Yes. So the central atom is nitrogen, which contains atomic number is 7. It means 1s2, 2s2 2p 3 is the atomic configuration, and then outermost electronic configuration 2s2 2p3, in which the electrons are 2 is there in s orbital, 3 electrons is there in p orbitals. It is an ground state of nitrogen. So in this, the electrons which are ground state 2s to 2p3. In excited state, no, there is no need 1s to 2s to 2p3. That's why here 3 hydrogens are there, which contains 1s1, 1s1 and 1s1. So these are all gives 3 electrons, 3 electrons each of hydrogen contains. By like this, which produce 1 sigma and 1 sigma and 1 sigma. It is called as lone pair of electron, lone pair of nitrogen. By this causes the molecule which is written as like this: NH bond H bond H bond H, and then it is a lone pair of electron, lone pair of, it is an lone pair of electron. In this, the bond angle in between bond pair and lone pair is 107 degrees 28 minutes. It means the presence of one lone pair of electron, the bond angle will be decreased from 109 degrees to 107 degrees. This is NH3 molecule, how they are in overlaps with each other, how they are intermixed with each other. It means it is 2s, it is 2px, and it is 2py, and it is 2pz, how they are intermixed with each other. Now I am going to intermix their 2s orbital of carbon. It is 2s, it is 2px, and it is 2py, and it is 2pz. It means the bond formations 2s and 2px, 2py, 2pz. So here 2s contains one lone pair of electron, 2px contain one electron. By this call 2px is contains 1, 2py and 2pz. And then here the 1s orbital of hydrogen contains one electron, and here also 1s orbital of hydrogen, which is intermixed with each other. Here also 1s orbital of hydrogen. By this causes 1 sigma. Here also 1s orbital of hydrogen, 1 sigma. So the molecule, it is lone pair of electron. This is the structure of lone pairs, and bond angle is, then hybridization is sp3, which contains one lone pair of electron. It is NH3, and I am going to now write the structure of NH3 and H2. Now I am going to taking the molecule is H2O. Here the configuration oxygen 1s2, 2s2, 2p4, in which the outermost electronic configuration is 2s2, 2p4. Now what is the excitation? Ground state of electronic excitation is 2s2, and it is an 2p4. It is ground state. What is excited state? Is there any need to excitation for 2s2, 2p4? No. So here only 2 hydrogens is there. We have only 2 unpaired of electrons. So hydrogen and hydrogen, which gives 2 electrons to us like this, and this is 2 lone pair of electrons. Then the molecular orbital structure of oxygen with water molecule is 2s. It is an 2s, 2px, 2py and 2pz. 2s and 2pz orbitals contains, what are they? 2s and 2px contains lone pair of electrons, and 2py and 2pz orbitals contains a hybridized orbital, which are intermixed by 1s orbital of hydrogen which forms 1 sigma. 1s orbital of hydrogen. By this causes 1 sigma. So this is the molecule, how the overlaps with each other, they can bond in between the two hydrogen atoms. By this causes the molecule shape will be written as O bond H bond H bond. Here two lone pairs are there. Two lone pairs are there. The bond angle here, the presence of two lone pair of electrons, which is 104 degrees 28 minutes. 28 minutes. So here the lone pair of electrons of nitrogen, which contains the shape is the nitrogen in NH3 molecule is what is the shape? Pyramidal or pyramid shape. Now then here also water molecule shape is bent or angular shape. This is the water molecule. And finally fourth one, then we can also take places like that. CCl4 molecule, CCl4, how they are intermixed with each other. Then the carbon contains 4 carbon atoms. One carbon atom contains 2s, and it is 2px, and it is 2py, and it is 2pz. Then hybridization can be also written as like this: 1s2, 2s2, 2p2, in which the CCl4 carbon is ground state, 2 electrons is there, 2 electrons, and p contains 2. This is ground state of the molecule. And then here also excited state, 4 electrons, 1s2, 2s2, 2p2. In this, one excitation will be taking place. First excited state is possible. By this causes carbon contains 4 unpaired of electrons in their first excited states. It is 2s, 2px, 2py, and it is 2pz. So by this causes 4 chlorine atoms. Now I am going to take the molecule is CCl4 in 17, the atomic number it is. It is electronic configuration Ne, 3s2 and 3p. 5 is the electronic configuration of chlorine. S contains 2, P contains 3 electrons, 4 and 5. So which is 2s, 2px, 2py, and it is 2pz. 2pz orbital is the pz orbital. Each pz orbital of 4 chlorine atoms of first excited state, ground state of 4 chlorine atoms, which are intermixed with 4 chlorines. By this causes 1 sigma, which is 1 sigma, and it is 1 sigma. By this causes the bond formations will be taking place like this. Here 2s is there, 2px, 2py, and 2pz. Yes, in this each of the chlorine atom of pz orbital, first chlorine atom of pz orbital is overlaps with 1 sigma. Second chlorine atom of pz orbital is overlaps with 1 sigma. Third chlorine atom of the pz orbital is gives like this, and 1s orbital, pz orbital of fourth chlorine is overlaps with 1 sigma. By this causes the molecule will be written as, the structure name is CCl4 is like tetrahedron, like this: C, Cl, 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 and Cl, like this. CCl4 like this, CCl4, the molecular structure. Here also the bond angle is 109 degrees 28 minutes. Then here the hybridization is also sp3. sp3. The molecules are totally 4 is sp3 hybridization. It gives the bond angle is like this. The structure, orbital structures of CCl4, and electronic configuration and excitations, how they are intermixed with each other. This is the sp3 hybridization.